Hey, Algebra 1. So today we're going to wrap up our last section of Module 2, which is 2.9, Compound Inequalities. We're going to kind of relate what we did yesterday with what we're doing today. So first, let's go through this. We have compound inequalities. They are two inequalities joined together with the words and, or. And we are going to graph basically both answers on one number line. And I will show you what I mean by that. So, or inequalities have a tendency to graph, and I forgot to fill the word in, apart. So what I mean by that is our example is for or, we have x is less than or equal to negative 2 or x is greater than 3. So first I'm going to plot the first answer on my graph at negative 2. We know it's going to be a closed circle, and that's going to be shaded left. Its x is greater than 3, so we have an open circle, and it's greater than, so it's shaded right. So when we say they're graphed apart, we mean that one's going in one direction and the other one's going the other direction. So from yesterday, if I had to graph x is less than or equal to negative 2, so if I'm talking about this side right here, in my interval notation, I would have negative infinity, comma, negative 2. It's a closed circle, so I have a bracket. Then it's going to be joined or unified with a u, and if its x is greater than 3, so now I'm talking about this side, I would have to do parentheses, starts at 3, and it's going to go on to infinity. So you're going to have now two interval notations brought together by the u. So let's run through some examples. You're going to solve them the same way that we're used to. So we can start with something a little bit more basic. So for number 1, we solve our or. So it's important to know that these are always going to be or. So first thing I'm going to do is add 4 to this one on the left. We know the 4's cancel, and we have x is less than negative 3. Then I'm also going to divide the other one by 2. So I have x is greater than or equal to 6. And you need to make sure that you are writing that it's the word or in between it, because x is less than negative 3, or it can be greater than 6. So we need to graph that. So we have negative 3. We know it's an open circle, and it's less than, so it's shaded left. The other one is closed circle, because it's greater than or equal to, and it's shaded right. Remember, interval notation is going to be two sets. One for the negative 3, so we know that's going on for forever at negative infinity. It's stopping at negative 3, but because I have an open circle, it's going to be a parentheses. It is brought together by a 6 closed circle bracket, and that goes on forever. Okay, let's go ahead and do number 4. For number 4, we have a two-step equation for both. So I'm going to solve the one on the left by adding 14. Should have 7x is greater than or equal to 14. We know to divide by 7, and so this x is greater than or equal to 2. We need another answer, so I will subtract the 5. And we have 4x is less than or equal to negative 8. Lastly, divide by 4. And so x is less than or equal to negative 2. Remember, we're talking about or statements, so make sure you write x is greater than or equal to 2, or x is less than or equal to negative 2. Okay, putting that on the number line. Let's start with greater than 2. It's equal to, so it's closed and shaded to the right. The other one is -2. It's closed, shaded to the left. And for interval notation, we're going to start with our negatives and then do our positives. So first, I'm going to start at negative infinity. It stops at -2. It's unified. It picks up at 2, closed circle, and then goes on forever. All right, number 5. We have another two to solve. And the one on the left, you need to distribute the -3 first. So go ahead and do that. And get -6x, subtract 3 is less than -15. And we will add 3. Get -6, x is less than -12. Divide by a -6, divide by a negative. And from yesterday, I reminded you, if you divide by a negative, you need to flip your inequality sign, and it's +2. Our other OR statement is 1 subtract x, so I need to subtract my 1. You cannot have a negative variable, so I'm going to divide by a -1. Flip your inequality sign because you divided by a negative, and then we have -4. Do not forget to write the word OR. Okay, let's go ahead and graph this and then do our interval notation. We have x is greater than 2. Oops. And it's greater than, so I should have done an open circle. And greater than goes right. X is less than or equal to. Now I have a closed circle. And I'm going to shade that one to all the smaller numbers and go left. Okay, so negative infinity. Stopping at -4, but it includes it. It is unified with an open parentheses, and it goes on to positive infinity. All right, so those are your OR statements. You also have something called AND statements, which is on the back page. So, AND statements have a tendency to graph, and the word should be here together. What I mean by that is, if there is let's go into the example. So here we have the word AND, so I'm going to graph both. X is greater than -6. We know it's equal to, so it's a closed circle. And if I were to shade all of this, I would go this way, right? We have x is less than 1, or equal to. That's a closed circle. And then I would be, I should probably use a different color, closed circle green. And then I would be coloring this way. So where it overlaps is this section right here. So that is technically your answer. So we didn't need to do this, and we didn't need to do this, and I'll show you the shortcut. For interval notation for this, it's very straightforward. Our dot starts at -6 and it's closed, and our next dot finishes at 1 and it's also closed. All right, so because the solutions to an inequality fall between two endpoints, they're frequently written in a more condensed form. So if I have, I'll rewrite the example, x is greater than or equal to -6, and x is less than or equal to 1, because they both are relating to the same variable, I would place that in the middle. -6 is smaller, so that goes on the left, and the +1 goes on the right. The inequality sign for x is less than or equal to 1 does not change, but if it's x is greater than, then you need to turn it around so that it matches. Because if you read the middle from the middle to the left, it's correct, and if you read it from the middle to the right, it's correct. If you need more help with that, let me know tomorrow. Okay, so let's go ahead and just do number 6. So for 6, we have another and statement. So I am going to solve these simultaneously. So what I mean by that is, even though we have a number and equate or something to solve in the middle and another number, I'm still going to solve for my variable x by subtracting by 4. Now instead of what I'm doing on one side, I'm actually going to do it on this side and this side. So I'm going to subtract all 3 places. We know from past experience that those cancel. We know that 2 subtract 4 is a negative 2. Bring down your inequality. You're only left with your variable. And then we are also left with our other inequality and a positive 5. Okay, from here we're going to graph. Really, this reads x is greater than or equal to negative 2. And this reads x is less than 5. So let's go ahead and graph those. X is what? Greater than negative 2? It's a closed dot. At 5, it's an open dot. And because the 2 arrows are pointed at one another, that is how you know to shade in between. So when you see a compound inequality or it says the word and, that means you shade in between. My interval notation starts at negative 2, ends at 5, and we would use a parentheses. Okay, let's go ahead and do number 8. Alright, so for 8, I am going to solve them simultaneously. I'm going to add 4 there, add it to the left, add it to the right. We know that's negative 12. Bring down your inequality. 4's cancel, and then we're left with 6. From here, it's 3 times x, so I'm going to divide each side by 3. Negative 12 and 3 gives you negative 4. We have x, and 6 and 3 gives you 2. Okay, hopping over to the number line, we are going to place our dots where they need to be. So at negative 4, you have a closed dot. At 2, you have a closed dot. And again, we are shading in between. Interval notation starts at negative 4, moves on to 2, and they are both brackets. Okay, so I'm going to do one more, and I'm going to go quickly. So let's look at 9. Alright, so now we have a fraction. So I'm still going to subtract 1 on all sides. To get rid of the fraction, you're going to do the reciprocal on each side. You need to cross cancel. To get 6x and negative 3. Hop over to your number line. We have an open circle at negative 3, a closed circle at 6, shading in between. Your interval notation is parentheses negative 3, and it stops at 6. Okay, what I want you guys to finish tonight, and I want you to try it, is number 10, and I will see you tomorrow.